With the geometric ones, I think what you need to really think about is how you would lay out the problem. That's probably one of the most important things you can do here, laying out the problem. So let's take a look at this question here. It says here, Anton is planning to save for a house purchase, deposit over a period of 5 years. And he opens an account known as a home saver and plans to pay into this account £200 at the start of every month and continue to do so for 5 years. So let's see what this is saying here. Yes, sorry, got a bit distracted. My boy was crying. So Anthony is planning to save for a house purchase over a period of 5 years. Okay, he opens an account and plans to pay into this account £200 at the start of every month and continue to do so for 5 years. So I'm going to kind of lay out the problem, and when I teach this, I really focus on how you present the data, the information given in a particular layout. Even like this, I laid it out in a particular way to really help me understand what was going on. And I encourage that. I mean, where you can't draw diagrams, you try and present it in a particular way. So let's look at how we present this. He's going to purchase deposit over a period of 5 years. So is how he's saving it. So let's write down first of all here year 1, year 2, year 3, year 4, year 5. And what he plans to do is pay into his account £200 at the start of every month and continue to do so for 5 years. So actually, I mean, in each year, we're actually really looking at monthly, isn't it? So maybe I should have written monthly, month 1, month 2. So he's going to have quite a few months here, 12 months times 5, right? So it's actually not a yearly one. Actually, let's just say month 1, month 2, month 3, all the way up to, what is it? How many months do we have? Well, 12 times 5, 60 months, month 60. And what's he going to do? He's going to pay into this account £200 at the start of every month. So month 1, we'll say this is the start of the month. How much is he going to put in month 1? £200. And he's going to continue to do so for 5 years. The account pays 0.5% compound interest per month, with interest credited to the account at the end of every month. Now, this is really important. We've got start and end. So how I lay out these problems, I'm going to adjust this. I'm going to say month 1 start, and I'll write down here finish. So this is month 1. Again, start, finish, month 2. I'll just call SF. You get the idea, month 3. Now, I don't need to do that for all of them. I mean, I'm going to be here forever, but the whole point of laying out for the first 3 or 4 months, just like we did here for the first 3 or 4 terms, is to spot the pattern. That's essentially what we're doing. We're trying to spot the pattern. That's what series are and sequences, number patterns. That's what we're working with. So start, finish. So what's he doing at the start of every month? He's putting in £200. But he also has what he had from the previous month, right? So let's go and take a look at how we can lay out this problem. 0.5% compound interest. Now, whenever we're working with interest, you can turn that into a decimal multiplier. So that would be 0.5%. So that's 1.005 will be the multiplier. So if you're timesing compound interest, timesing by 1.005 every time, okay? And so then this, because we're multiplying by the same number, it's going to be a geometric sequence here. Compound interest is always a geometric one because we've got a multiplier, i.e. timesing, a ratio, a common ratio. So what do they have at the end of the first month? It will be 200 times 1.005, or 200 times R. I'll use R because 1.005 is quite a mouthful or a handful to write. I'm going to say that's my common ratio. So I'm going to have 200R. So always, first of all, work out your multiplier, write that as a ratio, that's R, and then we can work with that R here. So there's fewer numbers. And if you're writing R, you can actually spot patterns a lot easier. So I've invested 200 at the beginning, and I'm going to have 200 R at the end of that month. In the next month, I invest another 200. And so what am I going to have in total at the end of that month? Okay, I'm going to have my 200 R from this one, but remember that 200 R that I had from before? I also had that, didn't I, here, 200 R. But what has that become? That has been multiplied by a ratio of R again in the second month, so it's become 200 R squared. Okay, so that's there. The amount from last, and this is the new one. What happens in my third month? Well, I invest a new 200, and that new 200 becomes 200R. I had that 200R from there, which I had, but that's become 200R squared. And then that 200R squared that I had from the previous month has now become 200R cubed. Did you follow that? This is probably the most important thing about this question, laying it out and understanding what's happening to the amount. So how much does this person have at the end of each month? Well, at the end of each month, at the finish of each month, this is what he's going to have. He's going to have a total of, at the end of the first month, this is how much he's got saved. At the end of the second month, he's got this much saved. At the end of the third month, he's got this much in his account. Okay. Did we understand that? That's probably the most important thing. Just can you just give me a thumbs up or not, or write down something in the comments about this. So I'm really trying to see how much money we're putting in at the start of each month, what we had from previous, and what we're going to have at the end of each month. And once you've got it laid out in this way, we can then approach the problem. So some comments, please, feedback before I move on. What do we have? Let's have a look. Okay, so we got people quite happy with that. So I've got quite a few thumbs up. All right, then. So let's move on then. So if you're happy with that, we can see what's happening here. This is how much we're going to have at the end. So what's it asking us? Let's see. The account pays. Okay, so we've just essentially written all of this information out in a tabular format. Show clearly that at the end of the third month, the balance of the account will be this. Now, because I've done this for actually month 1, month 2, month 3, this diagram is actually tackling that question without me having read that question in the beginning. So what is my balance at the end of the 3 months? It's this, and I have shown clearly there. That's fine. You don't have to write things. I mean, this is absolutely fine for the answer for part A. So then I would say the balance at the end of the third month will be 200 R. What is my R? Well, R is, remember, equal to 1.005. So then I would actually work it out for that value, 200, where R is equal to that. So 200, 1.005 plus 200, 1.005 squared plus 200, 1.005 cubed. That will be the amount that I have at the end of the third month. Done, and that should come out to be 606.02. Then it goes on to say calculate the total amount of Anton's home saver account after 5 years. So now they want us to find out what is the total amount that he will have in his account at the end of the 5 years. Now remember, this is the amount that he has. This is the total amount in his account. So understand what we've got for the third month. Total amount in account at end of 3 months. What is it? It's essentially whatever we've got there. That's what it is at the end of 3 months. So can we spot a pattern here? Well, I'm going to write down here month 3, M3. What does he have at the end of M3? He's got this. What does this form? Is this some sort of sequence? We can look at that in a moment. So where does it go to M3? It goes up to the cubed term. So this is where we're looking at pattern. So for month 3, it goes up to the cubed term. Second term, power of 1 there. Okay, is this some sort of sequence that we know of? Yes. Look at this series. We've got a term here, got another term here, another term here. How do we go from one term to the next? It's timesing by 1.05. So what's the common ratio? The common ratio is 1.005, right? Is there a common ratio? What's the first term? This is the first term. How many terms? What are we adding to? What are we adding to? Well, we're adding to everything up to, how many terms do we have? We've got 3 terms here, okay? So if I was to do a summation for 3 months, it would have been Sn, and since it's a geometric, I'll write down here, it's a geometric, and it's a summation here of the 1, 2, 3 terms. So it's actually S of 3 terms. What's my first term? A 1 minus R to the power of n over 1 minus R. How many terms are we adding? N is equal to 3. What is A? Well, I've identified what A is there. Remember, it's my first term here. What is R? So A is 200, 1.005. What is R? R is equal to 1.005. And then we can plug that in there to find out how much we have at the end of 3 months. Why am I focusing on 3 months? Because if I know how to do it for 3 months, I can then extend that to find out what it's going to be at the end of 5 years, which is at the end of 60 months. So I want to find out what it is for M60. Well, for M60, what's my thing going to look like? Well, it's going to look like this. Dot, 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 dot. Notice how I found the pattern. For 3rd month, it goes up to a power of 3. For 60 months, it's going to go up to power of 60. So what's my first term? A. What's my ratio? Well, the ratio is still 1.005. How many terms am I adding? How many terms do I have? First term, second term. I've got 60 terms, yeah? N is equal to 60. What's my summation? Well, it's a geometric, so the formula I'm going to use is this. And then it's a case of plugging things in. So the plugging things into the formula is the easy bit, as I said earlier with the sigma ones. But the most important thing is to try and establish how the way into the question, trying to find the pattern. How do we do that? By representing it in a nice kind of tabular format, representing it in some sort of nice diagram to help us see what the sequence is. Here, I had to do a kind of like a start and a finish to really figure out what's going on, how much money I have at the end of each month, how the money from the previous month continues. So a nice diagram. And with geometric problems, you will see this technique of laying out is very important to tackle these. Arithmetic is easier, yeah, but again, you can lay it out in a nice format. But geometric's a bit trickier. So this is the kind of strategy I always use, and I would encourage you to do the same to really see what's happening and then to figure out which formula and what to apply. Establish your first term, establish your ratio, just like we did here. We did the same here. We established what A and D, R, etc. is for that particular sequence.